Good morning, everyone. Today we're going to start a new course, Vector Differential Calculus. And in this course, we'll be covering a list of topics: vector basics, gradient of a scalar, divergence, curl of vector, line double integral, surface integral, Green's theorem, and Gauss divergence theorem. However, this particular session will be related to vector basics. So here we're going to discuss some vector basics that are going to be required to carry on onto this course. So at first we'll discuss about the quantities that we will be using in this course. So we have two quantities here. One is the scalar quantity and the other is the vector quantity. So scalar quantity usually only has the magnitude, which means a number given to represent it. So we could talk about an example here, which is mass. So we can have a person having 50 kg mass, not necessarily in left direction, right direction, or any other directions, but he just has 50 kg mass. So some other examples of scalar quantities could be speed, length, temperature. Now talking about vector quantities, we have here magnitude, but also direction. So in vector quantities, we have two things: magnitude and direction. One example of it we could talk about is force. So let's say there is a force of 50 Newton acting on a box, and the force needs to have a direction. So in this case, the force is pushing the box towards the left. So you can say leftwards. So then there is a direction with the magnitude in a vector quantity. And if we represent a function in scalar quantity, it would look something like 5x plus 3y plus 7z. While if we represent a function in the vector quantity, so let's say we have a function in the vector quantity here, it would look like 5x I cap plus 3y j cap plus 7z k cap. Those over there are unit vectors. So we'll just use a different color for that. So the I cap, j cap, and the k cap, those are known as the unit vectors. I forgot to give some example for the vector quantities. So some more examples could be velocity, acceleration. Now, let's say we have a point A and a point B. So the vector representing this line going from A to B could be represented like this: A with an arrow on the top. And here, the A is the tail or initial point, while the B is the tip or terminal point. So if we want to find out the magnitude of AB, it would represent it something like this. So if we want to find out, let's say we are given the 2 points A and B. So here, let's say that A is given as x1, comma y1, comma z1, and B is given as x2, comma y2, comma z2. In that case, if we want to find out the magnitude of A, we would have to use a formula where we take square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. That leads us to square root of a1 squared plus a2 squared plus a3 squared. I written the question before here, and we have got here our 2 points. The point P is 402, while the point Q is 6 minus 1, 2. So those are the initial and the terminal points respectively. And we have to find out the components of A and hence find the magnitude of A. So here, if we want to find out the magnitude of A, what we do is we take square root of x2 minus x1 squared plus y2 minus y1 the whole squared plus we have z2 minus z1 squared. So here we would have 6. Let's say we have here the Q points are x2, y2, and z2. And therefore the points of P would be x1, y1, and z1. So x2 minus x1 would be 6 minus 4, the whole squared, plus we have minus 1 minus 0 squared plus 2 minus 2 squared. So that would give us here 6 minus 4 is 2 squared plus we have minus 1 squared plus we have 2 minus 2 is 0, so 0 squared. And that's going to give us here 4 plus 1. And that is root of 5. So that's our answer. Now in the next part, we'll be talking about the addition or sum of two vectors. So here, let's say we're given a vector A. So let the vector A equal the position vector A1, A2, A3. And let's say we are given another vector B, B1, B2, and B3. So here, if we want to find out A plus vector B, then all we have to do is just take each coordinate. So we just take A1 plus B1, and then we have A2 plus B2, and then we add A3 with B3, and that's going to give us A plus B. Now talking about, let's scalar multiplication of vectors. So here we have, let's say, given the vector A again as A1, A2, A3. Then let's say we have a constant C and we're multiplying the C to the A vector. In that case, our answer will look something like this. So we have C times A1, comma C times A2, comma C times A3. So that would be our answer for scalar multiplication. Now let's go ahead and do an example on this. So here we're given the vector A as 4, 0, 1, and a vector B given as 2, -5, 1/3. Then find. So the first part would be to find out 7 times A. So that's a scalar constant 7 multiplied to the vector A. And in that case, you would just need to multiply 7 to every element in A. So we have here 7 times 4 would be 28. 0 times 7 will be 0, and 7 times 1 will be a 7. So that would be our answer for multiplying 7 to the vector A. And now if we are trying to do another question, let's say we are doing A plus vector B. So here we will just take each element, the first element added with the first element here, and second element added with the second element to the other vector, and so on. So here we will add 4 plus 2 is 6. Then 0 plus minus 5, that would be -5. And then we have 1 plus 1/3, which is 4/3. And for the third part, our question is to multiply the constant 2 to the answer of vector A plus vector B. So here, first, we add A plus B here. So 4 plus 2 is, okay, we already have the answer above. So A plus B is already given above. So we just can multiply 2 to this vector here. So we have 2 times 6 here will be 12. 2 times -5 is -10. And then we have 2 times 4/3. So that will be 8/3. And now if we do a fourth question, which would be 2 times vector A minus vector B. So here we have to do this now. So A minus B, so 4 minus 2 here would be 2. And then we have 0 minus -5, that will be 0 plus 5, so we have 5 there. And then we have 1 minus 1/3, which is 2/3. Now multiplying that with the constant 2, we'll get the vector here as 4. So 2 to the 4, 2 5s are 10, and 2 into 2/3 is 4/3. So I hope that much is really clear and simple. Yet, we will do one more example to make it more clearer. So here we have vector A given to us as 2, 3, 0, and vector B given to us as 4, -6, 0. So if we want to find 2 times vector A plus 5 times vector B. So we have 2 times vector A here, which will be 2 into 2 is 4, 2 into 3 is 6, 2 into 0 is 0, added to 5 times vector B. So that will be 5 into 4 is 20. And then we have 5 into -6 is -30. And 5 into 0 is 0. So that leads us to the result. So when we add this, we have 4 plus 20 is 24. 6 plus -30, that will be -24. And 0 plus 0 is 0. And going to the next one, we have to do now 2a minus 5b. So now again we have the same vectors above. So 2 times a would be 4, 6, and 0. But this time it will be minus 20, minus 30, and 0. And that will give us the answer as 4 minus 20 is minus 16. 6 minus minus 30, that will be 6 plus 30, 30, that's 36. And then you have 0 minus 0, that's 0. So I hope now the addition and subtraction using scalar multiplication is clear.